Imagine a situation where you are driving along in a road in your neighborhood and it's raining heavily. In around 15 minutes, your car gets filled with water and you got submerged. Sounds crazy, right? Actually, something like this happened in New York in September 2021. It was a flood caused by Ida hurricane that took the life of 16 people in New York. Flood is not even rare in New York. We're showing here a recent flood that hit New York in early July 2023, which took a life of a woman in her 30s. I'm Jax.
And I'm Asok.
We're working in the project named FloodNet at Tandon School of Engineering for this summer, and this project aims to deal with the flooding issue I mentioned before in New York City.
At FloodNet, we are aiming to build a network of real-time urban flood monitoring system. So actually in FloodNet, we are trying to build sensors like this. These are flood sensors which detect flood. This is one sample of the flood sensor that we have been deploying. So this sensor has one ultrasonic sensor. Many people think this is a camera, and there have been instances where people damage the sensor. This is not a camera, this is ultrasonic sensor. This is sensor body where we have microcontroller, battery, and other components that we need for the functioning of the sensor. And we do have solar panel in the sensor. The solar panel is used to charge the battery inside the sensor. So our sensor are self-sustaining. And this antenna over here, this is used to communicate data collected by the sensor to our gateway.
So this is a small demonstration of how we deploy the sensor in field. So in field, we find a straight pole like this or deploy one, and we have our sensor mounted on it and also our solar panel, but because I just have one hand over here, so I didn't put it over there. So this one is a ultrasonic sensor. Basically, it sends out ultrasonic wave, which is the sound we cannot hear, and it sends the sound to the ground and reflect back, and we keep measuring how long is the time range for one back and forth. And because we know the speed of the sound, then we have the distance from the sensor to the ground. So whenever there is a flood, the distance should be shrinking. That's how we detect that there is a flood. And when we gather the data for every single minute, we will have use this black antenna to send the data to our gateway. After we get the data from the gateways, we need to analyze that. So the first part of the analysis is actually data filtering, because the ultrasonic sensor will send very noisy data because, for example, like if someone parks their car under the sensor, then there will be like 1.5 meter immediate flood, and which is definitely not right. So basically what we are doing is trying to build up a machine learning model to filter out these outliers and to try to make sure that the data we get, the floods we detected are authentic, are real floods.
Another part of data analysis is making sure whether the sensor are in good condition or not. In FloodNet, we basically aim to deploy over 500 sensors, and since it's a really big network of sensors, we need to have a system that will detect whether sensors are working fine or not. In order to do that, we collect conditional data from each sensors, like the battery voltage, the network condition, and based on that, we train a model to classify the sensors. Like some sensor could be working fine, and another could be in low battery status. Another could have really bad networking condition, or other sensor could be sending really bad data. So based on these many wrong things that could happen with the sensor, we are trying to build a machine learning model that will classify and help us maintain this large network of sensor.
Yeah, and that is basically what we have been doing in FloodNet, and what FloodNet has been doing to New York City. And thank you for watching our project video.
Yeah. Thank you.